Hello everyone, I am Suchana Pramanik Jyoti, student of Department of Electrical and Computer Engineering. My ID number is 1510047. Welcome to my presentation on design and numerical analysis of prism coupled hybrid SPR biosensor, supervised by MD Mahbubur Rahman Sir, lecturer, Department of Electrical and Computer Engineering. This slide shows the outline of my presentation. Introduction, literature review, objectives and so on are included in this presentation. Introduction. Surface plasmon resonance or SPR is a phenomenon where the electrons in the metal surface layer are excited by the photon of incident light with a certain angle of incidence and then propagate parallel to the metal surface. SPR has performed as an optical detection technique for setting level-free bimolecular interaction in real time, which is used in several applications such as life science, electrochemistry, food and environment safety, and many other fields. Surface plasmon resonance occurs at a specific angle on the condition of attenuated total reflectance or ATR. Due to its simplicity, every commercial purposes SPR instrument uses a detection scheme called the Krushman configuration. In this setup, always incident light passes through the prism. Here, prism coupling technique is used to enhance the momentum of the incident optical wave. Light reflects on the back side of the sensor chip surface and come into the detector. This certain incident angle is also known as resonance angle. Light is absorbed by the electrons of the metal film, causing them into resonating electron. This resonating electron is also known as surface plasmon, which are sensitive to their surrounding environment. That occurs an intensity loss in their reflected beam, which can be seen as a depth in the SPR reflection intensity curve or SPR curve. The shape and location of the SPR depth can be used to convey the information about the sensor surface. When a molecular binding takes place, the angular position of SPR depth can be shifted. So, angular interrogation method with ATR is mainly considered to determine the sensing performance in terms of sensitivity, quality factor, and detection accuracy. Literature review. In literature review, one reported an SPR sensor where zinc oxide layer is used with gold, molybdenum disulfide and graphene layer to enhance the sensitivity. The proposed structure exhibits the sensitivity of 101.58 degree per RIU and quality factor of 15.11 degree per RIU. Limitation. The sensing performance is very low. We can use such coupling materials having lower refractive index to enhance the performance. In literature review 2 proposed a SPR based sensor using molybdenum disulfide between graphene and gold layer to enhance the sensitivity. The proposed structure has attained the maximum sensitivity of 87.8 degree per RIU with the quality factor of 17.56 degree per RIU. Limitation. It exhibits low sensitivity and quality factor. We can introduce a hybrid structured SPR sensor to enhance the sensitivity. In literature review 3 proposed a heterostructured SPR biosensor with molybdenum disulfide, aluminium and graphene layer. It shows the maximum sensitivity of 190.83 degree per RIU. Limitation. Fabrication process is complex due to the large number of layers. Krushman configuration can be considered to overcome the complexity. Objectives. The main objectives in this work is to design a simple prism coupled SPR biosensor based on Krushman configuration to intensify the sensing performance. Methodology. Angular interrogation method with ATR is used to determine the SPR performance. Reflectance intensity curve can be observed carefully to achieve our objectives. Transfer matrix method is used to characterize the performance mathematically. Here, MATLAB software is used as a simulation tool. Required mathematical formula. This mathematical formula is used to determine our findings. Proposed design. Proposed structure represents a hybrid structured prism coupled SPR sensor based on Krushman configuration consisting of BK7 glass as a prism coupler, gold layer, single layer of tungsten diselenide, single layer of platinum diselenide, and 3 layer of black phosphorus. Here gold is used as a SPR active material, and the newly invented TMDC material platinum diselenide with tungsten diselenide and black phosphorus play a vital role to enhance the sensitivity. The optimum thickness of platinum diselenide is considered as 2 nanometer. Results and analysis. The SPR curve is shown in figure 5 for the proposed structure. Here the SPR depth can be deviated for the change of refractive index of the sensing medium in the range of 1.33 to 1.335. The minimum reflection occurs at the resonance angle of 78.89 for the refractive index of 1.33, and the minimum reflection can be deviated by 1 degree, which is our findings to calculate the sensing performance. The structure exhibits the sensitivity of 200 degree per RIU. The refractive index of platinum diselenide depends on its thickness. The proposed structure with 2 nanometer thickness of platinum diselenide achieved the maximum sensitivity, which is clearly seen from the figure 6. Figure 7 shows the variation of minimum reflectance with respect to the angle of incidence. Black phosphorus layer has an impact to enhance the sensitivity. Adding of black phosphorus layer has the ability of wider the SPR curve, which prolongs the value of full width half maximum value. The full width half maximum term is related to the sensing performance parameter. 8 presents that the highest sensitivity can be achieved for 2 nanometer thickness of platinum diselenide with the 3 layers of black phosphorus. Different structures are analyzed to achieve our objectives. Mainly works with different thickness of platinum diselenide with black phosphorus layer presented by table 1 and table 2. When we used 4.4 nanometer platinum diselenide without black phosphorus layer, the highest sensitivity of 152 degree per RIU is observed. If we use 3.6 nanometer platinum diselenide with 2 layers of black phosphorus, it exhibits the sensitivity of 174 degree per RIU. But when we use 2 nanometer platinum diselenide with tungsten diselenide and 3 layers of black phosphorus, the highest sensitivity with acceptable quality factor and detection accuracy can be achieved. The proposed scheme offers a superior sensitivity, which indicates 1.47 times higher than that of the conventional structure. Comparison. In table 3, proposed structure is compared with different established structure. Suggested structure shows the highest sensitivity and quality factor among them, so I strongly demand that the proposed structure will create a good contribution in the field of SPR based biosensor. Future scope of works. In near future, we will try to fabricate the proposed sensor and work with newly invented 2D materials for the better performance. Conclusion. We are proposing a hybrid structured SPR biosensor with the sensitivity of 200 degree per RIU, quality factor of 18.59 degree per RIU, and detection accuracy of 0.09 per degree. References. Here is the references. And thanks to all.